What do wood and plums have in common? You never know what they taste like before you try.
No, but timber grading and sorting plums do have something in common. You perform timber grading to sort the timber into strength classes that have a certain strength, stiffness and density.
Imagine you have this pile of plums to share with your siblings, but you decide which ones you take and which ones they get. How do you manage to get the best ones? How do you know if a plum tastes sweet? Of course, you could just eat it. That's the single most reliable method to find out, but you wouldn't have any plums left to share.
It's the same in timber grading. You can only measure strength and stiffness by breaking the timber, and then you cannot use it anymore. This is why you actually measure some other properties that are somehow related to the properties you actually want to know. And the properties you measure are called indicating properties.
What are IPs? In your plum experiment, you do know the IPs automatically. You look at the plum and you squeeze it a little, and your brain automatically tells you, this plum is probably delicious. You take indicating properties like size, color and texture to estimate the tastiness.
In timber grading, we can measure things like knot size and acoustic velocity to estimate strength, stiffness and density.
How does your brain know that big, purple and soft plums are the best ones? It's because of your lifelong experience of eating plums. You have a large underlying data set. And this data set is super specific for the kind of fruit you're looking at. Take this plum, for example. Looking at it with your plum experience from before, you'd probably reject it, assuming it tastes horrible. But you'd be dead wrong. This is just a yellow plum, which is perfectly ripe and sweet. If you are grading with the wrong assumptions in the back of your head, grading doesn't work anymore.
Timber properties depend on the species, the forestry practices, the age of the wood and so on. You need to take the right assumptions into your grading equation to end up with the correct result.
After your grading experiment, you end up with different piles of plums. This is grade A, perfect plums for yourself. These are the intermediate grades, B and C. These plums are not perfect, but still good to use. And this is the reject. The plums are spoiled and good for nothing.
Now the important thing about grading is that its outcome is these piles of plums, not the individual estimation about individual fruits. We are always talking about populations when it comes to grading.
You can see it like this. Making your guess about the sweetness of an individual plum can always go wrong. In fact, you'll never precisely predict how sweet one tastes before you try it. But looking at your piles, the chance that these plums are, on average, sweeter than these ones is much easier to predict.
In timber grading, we luckily do not rely on the connection of your brain and your tongue, but we do measure some actual numbers. And that means in return, we also predict some actual numbers for the characteristic properties, strength, stiffness and density. But we do not predict numbers for pieces, but we predict the averages and fifth percentiles of the whole population.
You and your siblings ate all the grade A plums. But what happens to the lower grades? Well, many timber and plum products rely on averaging out defects. Lower grade timber can be laminated to make CLT or glulam, which is just like making a cake. You add some glue and put several pieces of timber together. The performance doesn't depend on single pieces so much anymore. You can go smaller and smaller in your particle size for lower and lower quality timber. Chips and fibers can be made into particle boards and MDF. And the reject? Well, usually wood rejects can still be used for something else, but in the last instance, you can always compost the leftovers or burn them for energy recovery. If you want to see how wood scientists actually find out about wood properties without tasting the wood, visit our YouTube channel or our blog. The link is in the post.